Hello, Rotarians. I'm so delighted to be talking to what is perhaps the greatest volunteer organization on earth. I know that Rotarians don't just talk about solutions, they take action, effective action to make a better world. I'm Michael J. Furness. I'm a soil scientist, hydrologist, and infrastructure vulnerability specialist. Thanks so much to Andy Barnett for setting this up. I wanted to give you a primer on water, its many important aspects, and touch on climate and water challenges and some calls to action. So let's go. So what makes the Earth the Earth? You might not be surprised at the answer. It's water. And Laura Knisley has said, if there's magic on this planet, it must be in water. There are many dimensions of water and watershed management, and I will focus on some of those things. Now, Earth is the only place we know of with water in all three phases: solid, liquid, and gas. Earth's water is at least 2 billion years old and probably older. And the amount of water on Earth does not change. It's been the same for that 2 billion years. And the basic thing to keep in mind is water has no substitutes. Unlike oil, there won't be a transition from water. What we have is what we have. And we can orient the globe such that nearly all we see is the immense Pacific Ocean. There are 326 quintillion gallons of water on Earth, or 326 million trillion gallons, or 332 cubic miles of water, if you prefer. And this illustrates how much total water there is relative to the size of the Earth. This is all Earth's water, and this is the liquid fresh water, and this is the water in lakes and rivers. And most of Earth's water is salt water. The amount of fresh water that supports people and terrestrial and freshwater ecosystems is relatively tiny. It's just 0.008% of the total. And here's a hydrologic cycle diagram, but don't worry about grokking this whole thing or all the numbers. The thing to notice here, though, is that there is a net transfer of 40,000 cubic kilometers from the ocean to the land every year. And this is why we have rivers and streams and lakes and a lot of water in the terrestrial and freshwater world we live in. And this makes the Earth the Earth. The problem with water really is uneven distribution in time and space. Some areas have too much water, others much less than necessary. And when it is present, the water is often in a condition that makes it unacceptable for specific uses. For example, if it's salty or polluted or full of sediment. And California is a good example of water coming at the wrong time. When it rains, demand is lowest. And when demand is highest, it rains very little. We're all quite familiar with this. And water is not in the places often where we need it most. For example, Los Angeles has far more people than the local water can support, so it needs to be brought from somewhere else. In this picture, you see Reno, and then its water coming from the Lake Tahoe area. And this is a picture of the renewable freshwater per person by river basin. And less than 1,000 cubic meters per person is considered water stress. And the Indus River in Pakistan, for example, goes dry in most years. And the Yellow River in China, China's mother river, less than 500 cubic meters per person per year for 300 million people. And it's been running dry in most years since 1972. So this shows the most water stressed areas on Earth. And this is all going in the wrong direction. It's getting worse everywhere. And it takes 1,000 tons of water to make a ton of food. And so you may think we don't have a global trade in water. We don't have big barges of water floating around and selling water that way. But we do have a global trade in water in the form of food, in the form of irrigated agriculture. Only 17% of agricultural cropland is irrigated, but it's 40% of the food that we get. So we do have a global trade in water, and it's a virtual form. It's in a virtual form in the form of food. And international basins are very common in the world and in the USA. And this requires cooperation. And nearly all international basins have agreements in place that allocate water. And the good news is that despite what many believe, humans do not go to war over water. There are tensions for sure, and winners and losers, but we tend to sit down and work it out. And despite what a lot of people think, there's no evidence of water wars. And it's a positive thing about humanity. We sit down and collaborate and talk about it and work it out around these international basins. And sometimes the water is plentiful, but is not usable, like here, a picture from Southeast Asia. The polluted water is difficult, costly, or impossible to use. So polluted water is similar to no water. And then globally, water contaminated with sewage is responsible for the deaths of thousands of children every day. And I'll return to this. But on the other end of the picture, the forested catchments have the best water quality. And so if your water comes from a forested catchment, it tends to have very high water quality. And this is a seminal study that was done that showed that the more forest cover there was, the lower the water treatment costs to make water acceptable for domestic use. And then back to this, each year, diarrhea kills around 500,000 children under 5. And this is an ongoing global catastrophe. There are 1.7 billion cases of childhood diarrhea diseases every year. And it's always occurring, so it does not make the news. And this is basically an effect of poor sanitation, where there is sewage getting into the water, and it causes these diarrheal diseases and this terrible death count. 500,000 children under 5 a year. And I wanted to touch on climate change. It's not a climate change talk, but it has huge implications for water. And then this is just kind of a quick climate change 101. It's warming. It's warming very rapidly, more rapidly than we normally see the Earth warm. It's us, and we're sure. Human greenhouse gas emissions are the cause of the rapid warming we see. And this is a scientific consensus now, and it's a consensus based on the literature that's as good as it gets. And it's bad. We can see this happening all over the world. It's relatively small right now, but it's all going in the wrong direction. And we can see that, and we can look out decades ahead and see that it will be worse, much worse for our children and their children if we don't get a handle on it. And then finally, we can fix it. There are plenty of reasons to be optimistic and hopeful about this. It won't be easy, it won't be cheap, but there's lots of things that we can do. And if we do most of them or all of them, we can fix it, and we can get on top of this before it gets too bad. And then it's notable that most of the impacts and the suffering and the loss that's related to climate change is hydrologic change. And if you work your way around the hydrologic cycle diagram, you can see that all of these components of the hydrologic cycle are affected. And the most significant manifestation of climate change is this acceleration and intensification of the global water cycle associated with changing precipitation patterns, the intensity and extremes, floods and droughts, and so on. For example, this week Pakistan had unprecedented and devastating floods, the most damaging ever. Many have died. The area underwater in Pakistan is larger than Colorado. And then earlier they saw summer temperatures of 127 degrees Fahrenheit. And heat affects water in many ways, including drought severity, wildfire, snowpack, runoff, and so on. And speaking of snowpack, here's a projection by the Scripps Institute of what the loss of snowpack in the Sierra Mountains of California would do. And there's a saying in California about climate impacts. There will be a lot less snow, and that's all you need to know. Well, you might need to know more than that, but this is really a very troublesome impact for California. And the reason it happens is because of heating, there's less of the precipitation falls as snow and more as rain, and then the snow melts faster and sooner. And so the real problem is that about 3/4 of California's water storage is in the form of snowpack. And that's a big problem. And it keeps water district managers up at night. And so this is what we're looking at in California, losing a lot of our water storage to this rapid heating that's going on. And so what can we do? Well, there's lots we can do. And I'm just going to touch on a few things. We can increase our water productivity. And there's a bunch of ways to do this in agriculture, in industries, in cities, and in homes. And in agriculture especially, which is the biggest user of water worldwide, we can raise irrigation efficiency. We can improve rain-fed farming. We can use regenerative methods that emphasize the increase of organic material in soils, which hold water and also hold carbon out of the atmosphere. And we can expand urban farming, as well as many other actions that we can take. We can expand drip irrigation. This is incredibly efficient relative to the way irrigation is done in many areas. And it's also worthwhile to link water, poverty, and health, and to meet basic drinking water and sanitation needs. And if we can link water and poverty and hunger, well, one way is to invest in irrigation for poor farmers. This can make a huge difference to help them put in irrigation systems and vastly increase their agricultural productivity. And here's a new water ethic from Sandra Prostel, a great water thinker, and that is to secure enough water for all living things before some get more than enough. And I have a few calls to action, and I know Rotary is really good with this and doing a lot of this already. And my local Rotary is big at getting clean water to poor places and people. And this is mainly a matter of tapping groundwater and providing sound sanitation. And the next one may surprise you, and that is the sheer power of adolescent girls. And this is a great leverage point for poverty alleviation, conservation of biodiversity, ecosystem services, climate change mitigation and adaptation, and overall human well-being and thriving. And that is, there are 600 million adolescent girls in the world, and about a quarter of them in poor countries never go to school. And for each girl that gets 7 years of secondary education, she marries 4 years later, has 2.2 less children, and makes 15 to 20% more each year for each year of secondary education that she gets. And this is huge. And this is something that is easy to do. You can do this individually. For example, I do by giving some funds to rescue.org, and they take care of the rest. I think that Rotary also is involved with these kinds of projects. The schools are there. The families just need money to send the girls. And so here are a few takeaways for you. First of all, water is what makes the earth the earth. Providing fresh water to poor communities, nothing new, but is still a priority action to take. And this is basically sanitation and groundwater. And then finally, educate girls in poor countries. And we can do this through organizations like rescue.org or Rotary. An organization like Rotary can sponsor these kinds of activities. And so thank you very much for your attention. And I appreciate the opportunity to speak to you today.